Hello everyone, welcome to Primus Learning. It's Aziz here today, and in today's series we are going to be looking at Helm. So first off, we are going to start by looking at Introduction to Helm, and then afterwards we are going to move forward to looking at the Helm architecture, and after that we are going to look at the various Helm commands, and then we are going to look at what a Helm chart is. We are going to look at what a Helm repository is. We are going to look at the various Helm repositories that are out there, and then we are going to look at what we call Helm templates. We are going to look at what we call Helm library charts, and then we are going to look at the various Helm functions that can help you to be able to implement very good Helm manifests. So without further ado, let's go ahead and look at Introduction to Helm. So to be able to understand very well the kind of the kind of scenario that Helm is actually coming to solve, you need to first of all understand very well what the current CI, what most companies actually use when they're not actually working with Helm, right? And in front of us here, what we have is just a single microservice. And normally in the microservice architecture, what most companies do is that they always have the Kubernetes manifest within the repository of the microservice. But in some scenarios, some companies might decide to store the Kubernetes manifest in some object storage like S3, you know. And then when they are doing the build, the continuous integration, after you finish building the artifacts, then now you can go ahead and you can, you can build the Docker image, and you scan the Docker image, and then you publish the Docker image to your Docker registry. And from there now you can now package your Kubernetes manifest, right? And now what we're really interested is what happens when you finish building that Docker image and you want to build your Kubernetes manifest. Because when you finish building the Docker image in a very well implemented continuous integration environment, what you should normally do is that you should then get the Kubernetes manifest, and in the Kubernetes manifest, what you want to do is simply get that current version of the Docker image you're just from building in your pipeline. You want to go ahead and update the Kubernetes manifest with this new version of the Docker image, and then you can now maybe store your Kubernetes, this new version of the Kubernetes manifest somewhere, right? That is normally how a good CI would normally look like. But now this very workflow is very difficult to implement when you're using bare Kubernetes manifest. Why is it very difficult? Because with bare Kubernetes manifest, you cannot be able to do versioning, right? You can only just maybe zip the manifest, and then you give the zip file, a name that is going to signify that this manifest was for this particular build and maybe for this particular microservice, and maybe this is a tag. Maybe it's a pre-release, or it's a release, or an official release, or whatsoever it is. And then you can maybe store it somewhere in like S3, and then when you want to deploy that very version, now you can then download the manifest from S3, and then you can maybe install it. That is basically what some CIs are going to do. Or at times what you can do is you just build a Docker image, and then now you have a separate pipeline where you're going to do your continuous delivery. And in that pipeline now you just need to provide maybe the version of the Docker image you want to deploy, and then it's going to go ahead and clone the various manifests and then deploy these applications for you. But for you to be able to have a very good continuous integration pipeline, right, you need to be able to version your Kubernetes manifest very well. And this is a very issue we have with working with bare Kubernetes manifest. You're not able to version your Kubernetes manifest because you're not managing your Kubernetes manifest. We're not managing your Kubernetes manifest very well, right? So the next thing we want to look at now is, okay, when you're dealing with multiple microservices, right? When you're dealing with multiple microservices, it becomes very difficult to be able to manage multiple Kubernetes manifests. Imagine you have 100 microservices, and in each repository for each microservice, you have a Kubernetes, you have a deployment YAML, you have a service YAML, you have a config map, you have a secret, and you have all these Kubernetes objects, right? Because in the bare minimum, you're going to have like six Kubernetes objects. So imagine maintaining all of these. If you're maintaining 100 microservices and you need to be maintaining you need to be maintaining 100 Kubernetes manifest, right? It's very, very tricky. It's very, very difficult to be able to manage. So you want a way where you can be able to manage your Kubernetes manifest very, very easily. And Kubernetes bare manifest are not giving you these things out of the box, right? Also, when you're working with bare Kubernetes manifest, you do a lot of repetition, right? You want to be able to template some things. You want to be able to, you want to be able to manage your use you do some tricks around your Kubernetes manifest to be able to reuse some components of the manifest, right? Because when you look at Kubernetes manifest, for example, in this deployment we're looking at, you discover that it's just a normal Kubernetes deployment. And if you have 100 microservices, it's going to be the same, it's going to be almost the same thing, right? So why not just define a template for a deployment, and you can just simply inject the various parameters, just a Docker image, and then it's going to deploy it for you. You cannot be able to do that with bare Kubernetes manifest, right? And when you're working with your bare Kubernetes manifest, it's very, very difficult to troubleshoot something before deployment. Like you need only to do a kubectl apply, before you know exactly if the chart is going to work, if the manifest is going to work, or if the manifest is not going to work. So you risk releasing things into production that are not very, very accurate. So with Helm, we are going to see that Helm gives us that ability, right, where you can be able to install a Kubernetes manifest and tell the cluster to wait. You tell Helm to wait until the application is up and ready before it actually marks that particular release as successful, right? And if the release is not successful, Helm is going to automatically roll back the deployment for us. You cannot be able to have all these advantages with your bare Kubernetes manifest, right? So that is what we're looking at. So with Helm, we are going to be able to manage our Kubernetes manifest, which means that we are going to have versions for each and every Kubernetes manifest, because you want to be able to you want to be able to manage your manifest as applications, because it's very, very it's very, very important. So if you look at what we have here inside the Helm directory, we have a very, very basic Helm chart, and inside here we have all the various parts of a Helm chart, which is the values YAML, the chart.yaml, and then you have the templates directory where you're going to put in your Kubernetes manifest, and then you can now make them very generic templates. So what we're going to be looking at is how can we take this Kubernetes manifest and how can we make these Kubernetes manifest Helm charts and make them much more generic, right, in such a way that we can be able to version them and be able to deploy our applications with ease, right? So Helm is simply just a package manager for Kubernetes. Look at Helm like the apt repository for Kubernetes manifest, or like the yum repository for Kubernetes manifest, where your developers just need to do a Helm pull and a Helm install, and they install the applications into the various Kubernetes clusters, right? And Helm is, with Helm you can be able to get already some public manifests, public manifests that are already that Kubernetes deployments, or some basic, or some applications that are already out there, right? Like the Prometheus and Grafana stack. If you want to deploy it, if you want to deploy Argo CD, all those charts are already out there in Artifact Hub, right? So with Helm you have what we call the Artifact Hub, and in Artifact Hub you have all public Helm charts, right? So first, in our next sessions, we are going to begin by looking at how can you actually install these Helm charts from maybe Artifact Hub, right? How can you get the Helm chart? How can you install it? And the various components that come in when you're working with Helm. So without further ado, let's go ahead and get into the next session where we're going to look at the Helm architecture, and we are going to begin by looking at the version by the v2 of Helm, what was there before, and then we're going to look at the Helm version 3, right? So I'll see you in the next lecture. Bye.